welcome to Coffee with the Editor. Yes,
Thank you so much.
I'm so sorry we couldn't do this in person, but life is complicated.
Yeah, we're just adjusting with the time, so yeah, we're making the best of it.
Well, you're all about virtual reality, so I think this is pretty much, the virtual side.
Very relevant.
What our reality would normally be.
Yeah, no, very true.
All right, so you put out a post the other day on LinkedIn, and I think it was the images that really grabbed me, and possibly, we're talking more and more about the digital twin of operations, and certainly it's coming through quite strongly in the mining sector. Talk to me about some of the stuff that you've been busy with.
Yeah, so just to give you a bit of a background, I'm currently busy with my PhD research project at the University of Victoria with my project supervisor, Prof. Hannes Grab, and he was also recently featured where you talked to him about condition monitoring and digital twinning of the railway environment. So in that context, my focus on the research is focused on incorporating new technologies, in particular artificial intelligence, on railway condition monitoring. So we're working with a company called Fortel that's based in Newcastle, Australia, and they are focused on the hardware and software side of digitizing railway operations using smart train technology. And with my research project, we formed a partnership where we're looking at how can we develop these technologies, how can we do railway condition monitoring more effective, more cost effective, making it easier, and then demonstrating there really is a use for all these buzzwords and the new technologies that are available on the market. So this it also forms part of the Engineering 4.0 theme that we have at the university. So with our new research campus where we actively work on these projects, we have the new state-of-the-art facilities available to actually deploy and optimize the technologies, planning a railway test loop, as Prof mentioned last year. So it's a culmination of us heading into the new fourth industrial revolution, but complementing it from the university side with the research projects that we are involved with, and then more specifically the research project that I'm involved with.
Ultimately, doing a virtual railway, I mean, like, you talk about the keywords and the buzzwords. I mean, what are the advantages of doing something like this? Let's say it's for Transnet or another operator. I mean, ultimately, what is the output goal here?
In the context that I'm working with, and the LinkedIn post that everyone has seen now, and what led to this discussion. The idea behind virtual reality or creating a digital twin is primarily if you can model something on a computer, you have much more control over that environment. You can add or remove certain deficiencies or distortions. So if you think of using a camera, for example, we can add motion blur, we can add depth of field, we can change the sensor sizes. So before we go onto the track, before we start playing around in the laboratories, we can model everything on a simulated computer environment. It's normally much faster, it's much more flexible, and also a lot more cost effective. And now also in the new COVID era, as we may call it, that we find ourselves in, it also adds a bit of flexibility. So in terms of my research, I've been working still unhindered at this stage because everything is running on a computer that's sitting just behind me here on the desk. So there's a lot more advantages to that, that just forms an intermediary step before we actually go through the expenses of acquiring hardware, testing it out on the field. We can eliminate a lot more potential flaws in the system before we actually implement it at the end of the day.
One of the railway lines, and I know that you're still looking at it from a research perspective, but just let's say Johannesburg to Durban, you kind of simulate that infrastructure and what it looks around. I saw one of your images where it looked pretty real, like I was actually on the track and I saw the grass passing by. But ultimately, your first pass, I think, is to get the current state as of that time what the track infrastructure is. And I'm assuming that you're looking at things like railway, the sleepers, the condition of that. You're getting a really good snapshot of the condition of that infrastructure right then and there. How is that then monitored going forward? And then like what kind of technology are you using to pick up, you know, the state of that track?
In terms of capturing a real environment, so in my case, I can model for my now just the project in context, an ideal case scenario. So I can model a bit of the surrounding purway, I can model cracks in the railway sleeper, the geometry, so that's more the focus that I'm looking at, the railway, as you mentioned, everything can be defined in that digital model. So that's very useful for training artificial intelligence networks. And then once we're out in the field, like you mentioned, between Johannesburg and Durban, for example, we can use our road rail vehicle that's equipped now with cameras and sensors such as LiDAR to digitize the surrounding environment. And based off of what we can train these neural networks or our calibrated models on in the virtual reality environments, once we capture that data in the real world, we already know what to do with it, how to monitor the conditions. So if we go out today, next week, next month, we can track the deterioration for particular areas and spot those areas which require critical maintenance based off of those measurements. So again, it forms sort of an intermediary step between going out, getting all of this data out in the real world, and where we can, in an enclosed environment, specify exactly what we need, develop models that can predict the deterioration and that we know actually works before we go out into the field.
From an operator's perspective, this would add tremendous value in terms of being able to predict exactly where the wear is happening, if they need to replace any of the track, and what needs to happen. Because I'm assuming you'll be able to see or be able to pick up any changes to the formation, the track bed formation, as well as the wear of the track itself. Is it necessary? I mean, I know right now you're using, your dedicated rail vehicle to do all of this, but in the future, can this equipment not be attached to the actual locomotive running on that line every day?
Yes, so that's the ultimate aim. I think that's where the research space comes in to actually define what type of sensors or technology do you need, what level of accuracy do you need. So we can buy the most accurate sensors, but they are rather expensive. So can we not use cheaper, more readily available technologies that's commercially available, installing them on revenue earning vehicles? And ultimately, once you define everything that's required to address a particular need, for example, the railway or the geometry that I want to measure, then we can say we can use this class of components. This is the framework that we need, the hardware, the software infrastructure, whether that's now in the cloud, if we can stream all of this data somewhere, then we can just duplicate this across locomotives, for example. So if it's on the front of the train consist every time, you will have multiple passes per day going over that particular point, and hopefully then we can have cost-effective, permanent monitoring solutions for railway tracks. So instead of just our little RRV that we're using, we can deploy that on a nationwide scale at the end of the day. So that's the hope and the aim that we're working towards at the end.
There's obviously a lot of data that comes back to you. What are the questions, or how do you get the right answers? So what are the right questions in order to get the right answers so that the data that you're getting is useful? And then what other uses would that data have long-term or for a different aspect of railway operation?
Big data is definitely the buzz term, and everyone always just talk a bit on the theoretical side. We're starting to deal with the practical implications of what do you do if you, for example, capture a few thousand photos of a railway as we go along now with the road rail vehicle. This is one of the questions that I'm grappling with at this stage. So in essence, you have a big collection of data that you ultimately want to distill into useful information. So in the past, we already have a lot of models and predictions and ideas of certain thresholds that may be met that indicates or flags a segment of railway that requires maintenance. So the idea behind taking all of this big data environment, if we go over the rail multiple times per day instead of only a few times per year, you're exponentially increasing the amount of data that you have. So if you can automate the analysis process to a large extent, you can ultimately have an automatic system that looks at this big collection. If it's now cloud points generated by LiDAR, or then a sequence of images that you have from a video camera sitting on the front of the vehicle. Once we've developed these models or neural networks that's able to process all of this data, the ultimate aim will be to say, once we exceed a certain threshold or a certain parameter, which we have a good understanding of just from the more basic theoretical understanding of our railway environments, then that can be flagged for to be maintained by a dedicated team. So it's linking how do we process this information without it being too laborious at the end of the day. How can we automate this? And I'm still a big fan of saying AI in that context. It's able to process a large amount of data into usable information that can be linked to a large extent to existing systems. And once we have that, then we can have a closed loop system of these information technology systems flagging a certain area. Please go and fix that area of the railway track, whether that is now railway, geological conditions. We can even extend that to things like ground penetrating radar, or then optical systems. So, and this links back to things like building information models, which is also taking off quite a bit more recently, where we integrate everything now into what we call a digital twin. So everything that we can measure of a real railway track, put that in the model, but then have some sort of algorithm or software infrastructure process this big amount of data into usable information that can be acted upon in the real world.
So jobs of the future. So if we take this kind of intelligence and progress that's being made in terms of 4.0 and digitalization and the Internet of Things, those lovely buzzwords, what do you think is going to be, I mean, you're a youngster now, in 5-10 years time, how will this sector of the industry completely change in terms of jobs and the automation thereof?
So that's I think a very pertinent question. I think it's still an age-old problem that we're tackling, but we're just trying to apply newer technology to the problem, and that's primarily condition monitoring and maintaining existing infrastructure, because if you just leave it, everything deteriorates eventually, and it needs to be kept up to date. So in terms of future job prospects, it's my hope that the engineers of today, the students of today, can really embrace the new technologies that are available. So we always tend to focus your civil engineer, this is sort of what your job description is. And what we're seeing more and more is, with the exposure that we have to new ways of analyzing data, whether that is now AI developing neural networks or data analytics, or being able to utilize and understand new measurement technologies. So it's sort of a convergence, what we now term civiltronics, so similar to mechatronics, but in the context of civil engineering. Is to have an understanding on how to incorporate these different spheres, because they are actually complementary to one another. So in terms of jobs of the future, I think these skills are very relevant, that needs to be taken up by students and even the existing professional body. There's really powerful new ways of monitoring the railway line and doing it more cost effectively, handling these big data applications, because we're already sitting with it. The question is, what do we do with it? So in terms of data science and IT and AI that's coming together, I think that's the area where we're heading to. and hopefully we can get a few people that's very passionate about the technology, and then to develop solutions for the South African context. I think we a very unique country in terms of the infrastructure that we have and the types of solutions that we can develop and deploy at the end of the day.
How would this technology work? So we want to build new rail infrastructure. So think about a high-speed rails to connecting Johannesburg, Durban, Cape Town, all the rest of it. How could this technology be applied in building new infrastructure?
So the big focus these days is also to have a smart train dump track type of approach. So instead of investing heavily into track infrastructure that is very often either vandalized, or we always have issues in terms of signaling equipment or theft of copper cables, for example. So rather invest the intelligence and the monitoring solutions on the train itself. So creating an intelligent train system. So less reliance on track infrastructure. And it's not necessarily to what some people think of, we're replacing drivers of trains entirely or the engineering crew. It's complementing the human capabilities at the end of the day. Similar to where we have self-driving cars, it's not entirely eliminating a person behind the wheel, but it is creating a more safe environment. So if you look at the statistics, the number of deaths per 100,000 miles for electric vehicles is already lower than non-AI vehicles. So it might not entirely eliminate all the problems that we're currently experiencing, or derailments or operational challenges, but it can improve safety and efficiency to a large extent if we can have the relevant IT systems facilitating operations and the human capabilities that goes into a railway track at the end of the day. Then again, we can also focus on, in terms of green technologies, how in terms of energy usage, if you look at the optimization that software systems can also bring in terms of operating the train vehicle. So there's a lot of scope to say we can leverage this technology to just have a more cost-effective system at the end of the day. We will still build our railway tracks with soil and ballast and rails. That's not going to go away anytime soon. But all the other aspects of the railway can be digitized to a large extent, or be outsourced almost to intelligent systems that can assist us.
So how much longer have you got until you finished?
So at this stage, I'm officially registered for my first year of PhD, but I've already been working on it. It's close to 18 months now, so still about 18 months to go. But luckily making very good progress on the side. Like I mentioned, with the use of computers, it's actually assisted us greatly in just mitigating all the disruptions that's associated with the pandemic. But our activities are resuming on campus, of course, under the guidelines of the relevant health and safety precautions. So very exciting times. Our road rail vehicle is nearly up and running. So hopefully we can start having a truly intelligent inspection vehicle that we can play around with, and of course do some interesting and relevant research too that can spill over to the industry as a whole. So very excited about the future, the new campus as well. So I think there's never been a more exciting time to be a student as well. We're no longer in the midst, I think, of the fourth industrial revolution. I think we are smack bang in the middle of it at this stage.
And then because it's Youth Month, I think it's poignant that you have a little snippet that we can use just from a youth perspective and a railway perspective.
Yes, so I must say it's interesting now talking also to some of the younger students. You're sort of now progressing, you no longer think of yourself just as an undergrad student, you're sort of now halfway in between. The current year has highlighted again the uncertainties that go with just life in general, but also disruptions in terms of technology that we're experiencing. The youth of today are growing up in a very different environment than my parents did, also to a large extent that myself has grown up with. So I'd say embrace all the opportunities you can get, the access to all the information that you also can access through the use of digital resources. It's really a powerful tool to educate yourself. So in the context of, we always think of just the university, you can teach yourself a lot of skills using digital technologies, and the things that I'm using now for my own research project. When I was a youngster, I always played around on the internet and read everything up that I could that was available. So it makes you a much more rounded engineer to a certain extent. Yeah, so interesting times that we are growing up in. I also, when I was a student, we had the fees must fall protest on campus. So it shifts your way of thinking of, in terms of your education, what it means to get an education and the exposure that you get at university. Just make the best of the opportunities that you have available. Don't worry too much about tomorrow. Tomorrow eventually comes your way as well. And yeah, just keep your head above water. We will get through this at the end of the day.